Yes, sir.
Yeah, so this is your proposed architecture name. Call it as a LCNN AKMP. That is called a lightweight CNN enhanced authenticated key management protocol. What it uses in the proposed architecture is nothing but we are comprising various components, software components and hardware components and connections among them, and we are prioritizing computational efficiency through security assessment in IoT settings. Then coming to next lightweight secure protocol for cloud IoT, it follows the steps like cloud assisted IoT. That means without internet we cannot perform any cloud service based application. Then from the cloud environment we are giving service to the IoT devices like server or system or any kind of platform. Then a lightweight cryptographic protocol module we are performing and choosing and leveraging and integrating. Authentication and key management mechanism we are performing. Then a data encryption model from a plain text to ciphertext we are converting for improvement of security and enhancing the security management. Then convolutional neural network for security analysis and threat detection module we are performing. Then resource optimization module we are performing, and then a user interface for authentication management. Then this proposed architecture and proposes and efficient communication in cloud assisted IoT environments by integrating lightweight cryptographic protocols and advanced CNN techniques for security analysis. So there are steps like IoT devices. What are the IoT devices we are using, like end devices, nodes or servers or systems and data center connected to the cloud requiring secure communication. Then lightweight cryptographic protocol module. In this module what we are doing, we are collecting the core component responsible for implementing lightweight cryptographic algorithms. Then authentication and improvement management mechanism ensures secure authentication and key management we are performing in the third step. That data encryption module, what we are doing, we are encrypting the data, that is a plain text to ciphertext or ciphertext to plain text according to user requirement to ensure confidentiality and integrity we are achieving in this data encryption module. Then CNN for security analysis and threat detection module. What we are doing, we are integrating and use CNN techniques to analyze and detect potential security threats. Then we are going for resource optimization module. It ensures efficient use of computational resources, maybe in a system, server and data center. Computational resources like we are using a data migration, and we are mirroring of data from one node to another node. So that we are optimizing with the help of in this resource optimization module. Then we are going for user interface for authentication management. What we are doing, we are providing a user friendly, that means echo and a eco-friendly interface for managing authentication process. Then what are the algorithm steps in order to perform our advanced protocol for cloud IoT proposed system? We are using various steps like initialization. What we are doing in this initialization, we are defining the IoT devices with the cloud infrastructure, maybe a server or system or a data center, and communication channels. We are initializing cryptographic parameters and keys. Then we are doing data collection. We have already created synthetic data or simulated data. That data from IoT devices, including device ID, timestamp and sensor data, we have collected the data. Pre-processed data. Why do we want to do pre-process, Prashanti? In order to eliminate noisy data, inconsistent data, redundant data, dirty data, we are using pre-processing mechanism. For that we are using various filters, box plot technique, binning technique to ensure consistency and format suitability for cryptographic processing. Then the third step in my algorithm, proposed algorithm, authentication mechanism. In this authentication mechanism, what we are implementing CNN based authentication mechanisms to verify the identity of IoT devices. We are extracting features from the collected data using CNN. We are comparing extract features with the stored authentication data to validate devices. Then key management in this lightweight cryptographic keys. For secure communication, distribute keys to authenticated IoT devices using secure channels. Especially, it can perform periodically update keys to maintain security. Then the fifth step is encryption and transmission of algorithm. What it does, encrypt data like plain text to ciphertext using lightweight cryptographic protocols. It can considered for IoT devices. It transmit encrypted data from IoT devices to the cloud security. Then ensuring data integrity and confidentiality during transmission. Then data analysis and processing. Perform data analysis on the cloud to extract insights and actionable information. Use a convolutional neural network technique to detect and predict anomalies. Anomalies is nothing but errors or intruders attacks, cyber criminal activities, something phishing, something vulnerabilities, that is called anomalies and potential threats in real-time environment. Then we are doing scalability management is nothing but we are increasing the size of the data. Automatically we are increasing the size of the data center. In this module, what we are doing, parallel processing capabilities of CNN to handle increasing numbers of IoT devices. It can allow number of Internet of Things devices. It can ensure the system adapts to growing data volumes and device connections without performance degradation. And I am explaining in this scalability management module, we are performing the size of the data especially. Then resource optimization, what we are doing in optimize computational resources to reduce overhead on IoT devices. We are implementing efficient algorithms to maintain energy consumption and processing time. Then the ninth step in algorithms like implementation and integration, we are integrating the cryptographic protocol with existing IoT infrastructure, seamlessly ensuring compatibility with various IoT platforms and devices. It provides a user-friendly ecosystem interface for administrators to manage the systems. Then testing and validation. Testing is nothing but we are eliminating noisy or we are checking the errors are okay. So this is about testing and validation. Then we are finally monitoring and maintenance of the IoT devices. We are transferring the data from one node to another node. Then we are stopping. So theory part I am avoiding and experimental setup I am coming to explain. In this experimental setup, it involves various proposed lightweight cryptographic protocol within a simulated cloud-assisted IoT environment to assess its performance, like various IoT devices, and it connected to the cloud. Why should we are connecting to the cloud? Prashanti, can you answer to my question? Why we are connecting to the cloud environment? Any answer from your side?
For storing the data of the IoT devices.
Prashanti, don't tell usual trivial dialogues. Specific answer you need to deliver because you are not a UG student, you are PG student. They are expecting very accurate and correct technical answer. Why we are connecting to the cloud means, sir, in cloud environment, whatever the data you are migrating or installing or transferring or saving, without internet you cannot perform any kind of service based application. And whatever you told, majorly we are storing huge volume of data in a remote location in somewhere else, and we are applying various protocols to increase our security, efficiency and scalability are evaluated through our proposed and rigorous testing and validation across various operational scenarios. So the first we have implemented as convolutional neural networks, we got accuracy versus epochs. So we have taken in x-axis epochs, number of epochs I have implemented 20 epochs, and we got accuracy 99.82 percentile of accuracy we have achieved with the help of the CNN improvement accuracy with training iteration. Then training and validation loss versus epochs, and we have used epochs in the x-axis, and y-axis we have taken training and validation loss. So it explains training, it explains validation loss over epochs, indicating the model. Model is nothing but simplified version of the reality, it learning progress and generalization of capability. Then time complexity versus epochs, we are taking in x-axis epochs and y-axis time complexity, and it can highlight the reducing the time complexity over number of epochs, it illustrating the efficiency improvement of the model. Then this is about accuracy versus epochs. We have taken 20 epochs on the x-axis, and y-axis we have taken accuracy, and we have applied CNN model to improve over 20 epochs. Then we got a training and validation loss versus epochs. So in x-axis we have taken epochs, and y-axis we have taken loss, and training loss versus validation loss we are comparing, and this training and validation loss over 20 epochs indicating how well the model is generalizes and performing. Then the authentication time versus CNN analysis score, we have used in x-axis like success, authentication, failure. In y-axis we have taken average CPU, central processing unit usage in the percentage level. Then this scatter plot illustrates the relationship between association between a CNN analysis score and the authentication time. We are highlighting the model's efficiency. Then the results and training performance, we got very good accuracy and low final training loss, indicating the proposed protocol's effectiveness in learning the authentication patterns. Then the consistency levels, the consistently low training loss throughout the epochs demonstrates the model's capability to optimize and improve its predictive accuracy efficiently. The validation performance results confirmed the robustness of the proposed protocol, demonstrating consistently low validation loss across various scenarios. This indicates the protocol's ability to generalize well and maintain high security standards in diverse IoT environments. Then this results performance, by applying test performance we got very good results by applying lightweight cryptographic protocol, achieved high accuracy, low training and validation loss, and maintained time complexity, confirming its efficiency and effectiveness. The protocol demonstrated excellent scalability and robustness, making it highly suitable for secure and efficient cloud assisted IoT deployments. Then we are moving to comparative analysis. We are using various parameters in terms of existing and proposed system with validation parameters. Especially we are calculating accuracy, training time, loss, epochs, time complexity. These are the validation metrics like F1 score and ROC, AUC. There are various performance metrics, validation metrics we are using for justification of our model is performing well or not. The proposed system shows improved robustness, scalability, and reduced overfitting risk, making it highly suitable for secure and efficient cloud assisted IoT environments. Then this is the comparative analysis. Through program we have achieved parameter accuracy, proposed system 100% we got it, and existing less than that 100%, that is variable. Final testing loss we got 0.0016 negligible, and in existing system higher. Validation loss is very low in proposed system and very high in existing system. Time complexity 2 milliseconds per step we have achieved through proposed system, whereas in existing system it is very higher. Epochs we have used for 20 epochs. In existing system it depends on number of review papers we have surveyed. It variable. Interoperability is proposed in high. Existing system is very low. Convergence speed is very fast in proposed system and very slower in existing system. Overfitting risk is very low in proposed system and higher in existing system. Robustness is very high in proposed system, means any platform, any domain, any programming language can support for this protocol. In existing system it is variable. Generalization can support for proposed system is very excellent, and in existing system is variable. Then final discussion about our proposed technique called a lightweight cryptographic protocol demonstrates significant improvement in security and efficiency for cloud assisted IoT environments. However, we are using this proposed technique to address the challenges related to real world implementation and enhance its resilience, especially in terms of security performance against evolving cyber threats. Then what are the challenges and future work still remain in our MTech existing work? So real world sustainability and integration with the diverse IoT devices need further exploration. We have implemented certain IoT devices. Now you can use many number of diverse IoT devices so that we can increase our future work. So it enhances the protocol robustness against emerging cyber threats and expanding its applicability across various IoT ecosystem. The final conclusion of my proposed system, like lightweight cryptographic protocol, it enhances security, performance, validity, and efficiency in cloud assisted IoT environments. Through rigorous testing, it has demonstrated significant improvements in scalability, computational efficiency, and ease of implementation. We are addressing critical security challenges in IoT deployments. So these are the references I have used, and this is about presentation. Prashant,